And yung una po is for the solid fuels.
Good afternoon po. Sample problem number 1. Determine the mole fractions of a gas consisting of a mole of oxygen, 8 moles of nitrogen, a mole of carbon dioxide, and 2 moles of carbon dioxide. Determine also the mass fraction. What is the average molecular weight of the gas? So, dito po sa solution natin sa problem number 1, una pong kinuha, first sinulat muna natin, wait lang,
Anong problem
Ayan.
yan? About,
sa mole po. Ito po, mole fractions po.
anong analysis yan?
Yung pinakauna po, na yung kay Patricia po na part, yung pag-aalam po nung sa mass fractions po.
Okay.
First, sinulat muna natin yung mga given, which
Sige.
the,
May mouse ka ba? May katuro mo ba yan sa mouse?
ito po, ayan, 1 mole of the oxide, the nitrogen is 8 mole, then carbon dioxide is 1 mole, carbon dioxide is 2 mole. Then, first, kinuha po muna natin yung total no sa N.
Pwede mo bang lakihan yan? Lakihan? Pwede ba? Kaya ba yan? Lakihan?
Ayan po.
Yan. I-focus mo para yan. O, nasan ka? Nasan ka ngayon?
Ito po.
O, ano ibig sabihin
Kita po
yan?
ba yung mouse pointer? Ito po yung, kinuha po muna yung total N or yung mole of
Mole ba yan? Total mole?
Yes po. Mole po.
Okay.
Mole of the given, which is 1 plus 8 plus 1 plus 2. The total po niya is 12. Then next is, kinuha po natin is yung mole fraction oxygen. Mole fraction po muna ng oxygen. Focus po muna tayo sa oxygen ngayon. Then yung given na 1 mole ng oxygen is i-divide lang siya sa total of the mole we got, which is 12 mole, and we multiply sa 100% to know kung ilang percent yung mole fraction ng oxygen sa kabuuan. So 1 divided by 12 is times 100% is equal sa 8.33%. Then, ganun din sa nitrogen. Ilan po ang nakuha natin sa nitrogen? 8 mole po. Then, i-divide lang po natin siya sa total, which is 12, and multiply to 100%, which is with the total of 66.67%. Sa carbon monoxide, ganun din po. 1 mole is the given for the carbon monoxide, divide lang po sa total nilang lahat na 12 moles times 100%, 8.3333%. Then, mole fraction of carbon dioxide, ganun din. 2 moles ang given po sa carbon dioxide, dividing it to 12 moles, then multiplying to 100%, which is 16.667%. And pag tinotal po natin lahat, na nakuha po natin percentage ng mole fraction, we could get 100%. Yeah, 100%. Then, next naman is the molar mass. Ang formula po natin is yung nakuha po nating N, the mole, is, ito yung 1 mole, 8 mole. I-multiply natin siya sa molar mass para makuha yung mass mismo ng oxygen. Mass mismo ng mga elements na hinahanap. So, example, dito sa oxygen, given po natin is 1 mole. Then, sa oxygen, ang molar mass niya is 16. Since diatomic ang oxygen, multiply natin siya sa 2 with the, so, 16 times 2 is 32 times 1, 32 grams. Then, ganun din po sa nitrogen, diatomic din po siya, ang molar, ang ano po niya is 12. Then, dahil diatomic, multiply lang po sa 2. Then, multiply sa mole niya, na given, which is 8 mole, getting 224 grams. Then, sa carbon monoxide, 1 mole yung carbon monoxide. Then, carbon, ang ang ano niya is 12, then yung oxygen, since di naman naka-indicate na 2, 1 lang ang oxygen sa carbon monoxide, 16 lang, hindi siya i-multiply sa 2. So 12 plus 16, i-add lang yung mass nung sa molar ng carbon net oxygen, 12 plus 16, we get 28. Since multiply lang naman sa 1. Then sa carbon dioxide, 12 sa carbon, dahil diatomic, indicated na diatomic ang oxygen dito, 2, 16 times 2. So 12 plus 16 times 2, then multiply sa 2 na given as the mole, we get 88 grams. Then, after we get all of this, the 32 to 224, 28, 800 grams, 88 grams, we get the total of them getting 372 grams. Then, after that, after getting the total, we get the mass fraction. The mass fraction. Parang yung kanila din po sa mole fraction. In this case, yung mass lang ng per element divided by the total mass of the total mass times 100% para malaman natin kung ilan po yung mass fraction of the whole per element. Example dito sa oxygen, 32 po ang nakuha natin ng mass kanina, di-divide lang po natin yun sa total mass. 32 divided by 372 times 100, we get 8.6021%. Sa nitrogen, we get 224 grams, divide lang natin sa total of 372 grams, times 100%, we get 60.2151%. Carbon monoxide, we get 28 grams, then divide sa 372 grams, then multiply sa 100%, we get 7.5269%. Carbon dioxide, 88 grams, divided by 372 grams as 372 grams the total, times 100%, to get 23.6559%. Then, para po makuha na, then pag in-add din po iyan lahat, we could get 100%. Then, para malaman po natin yung average molecular weight, we get the total mass, 372 grams divided by the total mole of 12 mole. 372 grams divided by 12 mole, we get 31 grams per mole. Paano? Next problem, sample problem number 2. Wood chips with 40% moisture as received are supplied to a biomass power plant. What is the moisture content on a dry basis? So, ito po yung sa solution natin for problem 2. Ba tayo? Wait lang. Eraser. Ba tayo? Ayan. So, ang given lang po natin is yung 40% which is the moist content as received. So, i-convert natin 40% as a whole number, 0.4. Pag sinabi po natin moist content as received, pwede rin po is equal din po siya sa moist content over mass as received. Then, next, we get first muna yung moist content dry basis. Equal siya sa moist content over mass dry basis. Then, magde-derivation lang tayo na itong mass dry basis equal siya dito. Wait lang. Ito. Kunin natin yung equivalent ng MdB mula dito sa formula na to. na mass as received is equal sa mass dry basis plus moisture content. Kaya, manipulate lang natin to, makukuha natin is mass as received minus moist content. Then, after that, pwede natin yung mass as received na to, i-convert natin siya dito sa, yung sa kanina, di ba? Moist content as received is equal sa moist content over mass as received. Ngayon, pwede natin kunin mula dito. Wait lang. Kunin ko mula 10 dito. Ayan. Wala dito, kukunin natin yung value ni mass as received. Dito sa formula pa lang na to. Wala muna tayong ilalagay pa na values na number. So, mass as received, pag minanipulate ko yan, ito makukuha. Mass as received is equal sa moisture content over mass moisture content as received. So, kaya naging ganito ang kinalabasan niya. Batayaw. Wait lang. Ayan. Ayan. Naging moisture content over moisture content over moisture content as received minus moisture content. Then, ilalabas natin yung similar. Lahat ng similar sa kanila is the MC, the moisture content. Ilalabas natin sila para mag-cancel. Magiging 1 na lang siya. After that, yung moisture content dry basis ngayon is equal sa 1 minus 1 over moisture content as received minus 1. Yung moisture content kanina na nilalabas, naging 1 na lang siya. Then, equal siya sa 1 over moisture content as received minus moisture content as received over moisture content as received. Wala naman siguro na nalabag na rules or law of kung ano, kasi moisture content as received over moisture content as received equal din sa 1, di ba? Kasi both numerator and denominator are equal. Parehas lang, biging 1 lang din yan, di ba? Then, after that, pagkukumbala natin yung nasa denominator, ma-minus natin, we could get 1 over 1 minus moisture content as received over moisture content as received. Since parehas lang naman ilan ang denominator sa denominator, ulitin ko, parehas lang yung mga denominator sa denominator. Pwede sila, ang numerator ay pwedeng combine na lang. Then, after the next, itong moisture content as received na denominator sa denominator, gets ba? Yung moisture content, wait lang. Then, ito. Ito, ilalagay, pwede siyang ilipat sa numerator. Sa pinaka-numerator as nahula, hindi siya yung dito, na yung numerator sa denominator, hindi doon na. Sa pinaka-numerator talaga. Doon natin siya ilalagay. So, moisture content as received minus 1 minus moisture content as received. Ngayon, dito equal yung moisture content dry basis dito. Ngayon, may value tayo ng moisture content as received, which is 0.4. Pwede natin i-substitute, ipasok yung 0.04 para to get the moisture content dry basis equal, so 0.04 over 1 minus 0.04 times 100% equal po siya sa 66.6667%. Nakuha na po natin yung moisture content dry basis. Next, number 3, sample problem 3. The ultimate analysis of coal is given below: C, carbon, equals sa 8.5%, sulfur equals sa 1.5%, ash is 12%, hydrogen is 2.5%, oxygen is 3.5%. Calculate the heating value of coal. So, dito sa problem na to, hinahanap yung heating value. Well, assume na natin na hinahanap natin is yung high and low. Kukuha na din natin siya parehas. Focus muna tayo sa pagkuha ng higher heating value. So, sinabi kanina sa to ang formula 33,820 times carbon plus 144,212 times the hydrogen minus oxygen over 8 plus 93,045 kilojoule per kilogram as the unit. Then, since given, nakasaad sa given, i-insert lang natin yung mga values ni C, ni carbon, ni hydrogen, ni oxygen. Ang value ni ang given is in percentage, so i-convert pa natin siya as whole number. So, yung 68.5%, nilagay siya as decimal, naka-decimal 0.685. Then, sa hydrogen, yung 0.025. Then, sa oxygen, yung 0.035. And then, 9,304 pala, I'm sorry. Dito sa formula natin sa higher heating value is 9,304 times sulfur, yung S. Sorry. So, yung sulfur natin, which is given is 0.015. So, doing the math calculation, ito po nakuha natin, higher heating value is 26,280.6325 kilojoule per kilogram. We get the higher heating value. Next. Wait lang. To get the lower heating value, we need is heating value minus 9 times hydrogen times 2,442 kilojoule per kilogram. Then, ito, ano lang din, direct substitution lang din, kaso sa higher heating value, itong LHV, lower heating value, higher heating value, and itong H, as received silang lahat. Then, itong 26,280.6325 kilogram as received to, kasi yung higher heating value is as received. Minus 9, dahil, so water divided by the hydrogen times yung hydrogen na 0.025 kilogram hydrogen over kilogram as received. So we cancel the kilogram hydrogen. Then, ito pa pala yung 2,442 kilojoule per kilogram na of water, na-cancel din yon. So, ang matitira na lang is kilojoule per kilogram as received. Doing the calculation here, yan, we could get the lower heating value as received na 25,731.1825 kilojoule per kilogram as received. Next.
Next naman po is yung next sample problem. Basahin natin. Sample problem number 4. Calculate the minimum volume of data of 200 degrees API fuel having a fuel consumption of 1 kilogram per second if the temperature is 20 degrees Celsius. So, ang hinahanap dyan is yung volume ng fuel at 20 degrees Celsius. So, ano nga ba yung mga considerations dyan? We can see na yung mass flow rate niya is 1 kilogram per second. Ngayon, saan ba nakalagay yung fuel? Given sa problem, yung volume ng day tank. So, yung meaning ng day tank is usually 1 day or 24 hours. Ang tanong is, gaano kalaki yung day tank kung dapat siyang tumagal ng 24 hours kung ang consumption ng fuel ay 20 degrees Celsius. So, writing all the given, volume of fuel at 20 degrees Celsius, hinahanap natin. 1 day, 24 hours, 28 degrees API, mass flow rate is 1 kilogram per second, and ang temperature na i-consider ay yung 20 degrees Celsius. So, para makuha yung volume, meron tayong formula na density is equals to mass over volume. Dahil at 20 degrees siya, syempre ang kukunin natin is yung density ng fluid at 20 degrees. Well, hindi na natin lalagyan ng 20 degrees yung mass kasi kapag mass yung usapan, hindi niya na need lagyan ng temperature. Kasi kahit tumaas yung temperature niya, yung mass ng fuel ay hindi pa rin siya affected. Volume lang yung tinatamaan dahil sa expansion. And supported yan ng law of conservation of mass. Yung amount ng matter na nag-exist before and after change ay neither created nor destroyed. So yung temperature na i-consider is yung 20 degrees Celsius. So yung working formula to calculate yung volume ng fuel is yung density. Ang hinahanap dyan is yung, meron na tayong mass ng fuel. Ang hinahanap na lang is yung density. Density ng fuel, meron din siyang formula, which is yung specific gravity. Specific gravity is equals to the density of the substance over the density of water. Sa case na yan, ang hinahanap is yung density ng fuel at 20 degrees Celsius. So kanina, may diniscuss na SG sub 15.6 degrees Celsius. Ang meaning niya is yung specific gravity ng temperature at yung specific gravity ng fuel na yung temperature, yung 15.6, ayun yung temperature kung saan siya initially nabili. So, yun yung baseline na temperature. Ngayon, alam natin na ang density ng water is 1,000 kg per cubic meter. Ngayon naman, isosolve natin yung SG niya at given temperature. So, yung una muna is isosolve natin yung store-bought temperature na specific gravity dahil ang given sa atin is yung degree API. Meron tayong formula na degree API is equals to 141.5 divided by the specific gravity at 15.6 degrees temperature minus 131.5. So, isa-substitute lang natin yung value na nakuha natin. Makakakuha tayo ng 0.8871 na specific gravity at 15.6 na temperature. Ngayon, para makuha yung specific gravity na temperature na pinainitan na yung fuel, gagamit tayo ngayon ng correction factor. Yung correction factor is yung makikita nyo dyan na 1 minus 0.00072 minus the desired temperature ay multiplied by the desired temperature minus 15.6, which is yung baseline natin. So, plugging in the value na 20, makakakuha tayo ng specific gravity at 20 degrees Celsius na 0.8843. Ngayon, na meron na tayong specific gravity, makukuha na natin yung density ng fuel. We just have to multiply 0.8843 multiplied by 1,000. So, ang density na ng fuel natin is 884.3 kilograms per cubic meter. Since meron na tayong density, makukuha na natin si volume ng fuel. So, ang volume ng fuel is equal to the mass ng fuel, 1 kilograms per second, divided by the density ng fuel, 884.3 kilograms per cubic meter. Base dyan, makakakuha tayo ng 1 over 884.3 meter cube per second na volume. Kaso nga lang, ang
Excuse me, bakit dinivide sa 1,000 yan?
density po ng water, sir.
Yung 1,000 kilogram per meter cube?
Apo.
Okay.
Apo. So going back, dahil yung unit ng volume natin is naka-second, and ang hinahanap is volume ng day tank, which is 24 hours, kailangan natin i-convert yung seconds into days. Now, by calculation, makakakuha tayo ng volume ng fuel at 20 degrees Celsius na ang value niya is 97.7055 meter cube per days. Yan na ngayon yung sagot sa problem na gaano kalaki yung day tank na kailangan para tumagal ng 24 hours na nagko-consume ng fuel at 20 degrees Celsius. Next problem naman po is continuation lang din nung unang problem. Ngayon naman, ang hinahanap is yung heating value ng fuel na may 28 degrees API using the ASME or the Bureau of Standards formula. So, proceed tayo sa solution. By the way, yung sa solution niya, given na yung formula. Yung high heating value, 41,130 plus 139.6 multiplied by the degree API. By plugging in the 28 degrees API, makakakuha tayo ng high heating value na 45,038.8 kilojoules per kilogram. So, solving naman, gamit yung Bureau of Standards formula, yung high heating value natin, 51,716 minus 8,793.8 multiplied by the specific gravity at the baseline temperature squared. Ngayon naman, kukunin natin yung specific gravity at yung store-bought temperature niya, and gamitin na lang natin yung nakuha nating value earlier, which is yung 0.8871. By plugging in the values, the higher heating value is equals to 51,716 minus 8,793.8 multiplied by the nakuha nating value na 0.8871 then squared. So, ang high heating value niya is 44,795.7507 kilojoules per kilogram. So, take note lang dito, usually, ang ginagamit sa industry is yung degree API kasi mas accurate siya compared dun sa degree BOME na na-discuss kanina dun sa topic. And that concludes our presentation about the properties of fuels, solid fuels, liquid, gaseous, and alternative fuels. Thank you.